Dear students, so today we will talk about visualizing the variability. What does it mean to visualize the variability? It means that when there is a variation in the data with the progression of time or with the progressions of any second variable, that how visualization changes, how the effect is being done. So, in this chapter, what are the learning objectives we need to have it? So, we need to interpret and create some charts which will be based on some frequencies with respect to categorical variable, means like the variable which is based on textual data. Like then the second objective, a learning objective of this chapter is to create and interpret the histograms and frequency polygon and chart used to visualize the distribution of quantitative variable, that if the variable is quantitative, then how the chart will look like and how it will variate and how it will change. And the third most important objective is to have interpret the visualization comparing the distribution of two or more variables. In case if there are two or more variables, then how the visualization will be changed and how we can interpret it. And the foremost important learning objective would be that to create and interpret the script charts, recognize situation to use them, how to employ them, and how to improve the clarity. The fifth objective of this chapter is to describe the statistical measure of central location. That what is a central location means that mean value, average value, mode value. That's called centrality or central location. And the variability, how it changes with respect to, like, with the central position, like variance or standard deviation, and the distribution shape. So we have normal distribution, skew to the left, skew to the right. And then in 5.6, we will talk about like how to create and interpret the box and whisker chart, how box and whisker chart can be interpreted with respect to the anomalies. If some points are away from the whisker box chart, so we can call it as an anomaly. The seventh objective is to create and interpret the visualization that depicts the uncertainty resulting from sampling error. So in case if we take the wrong sample, what will be the impact on the visualization if the sample is taken wrongly, if the sample is biased, if the sample is not properly random, if the sample is from a specific area, not from the whole population. The eighth is how to create and interpret the charts that depicts the uncertainty in prediction. For example, how we will know that by visualization, how we can know that there is a uncertainty in prediction, or there is a probabilistic approach in the specific chart with respect to a simple regressions model and with respect to the time series model. So these are the learning objectives which we will cover today in the chapter. This is one of the makeover case study for your data visualization, that how frequency polygon chart for US Olympic Games, it changes with respect to the time. So on the x-axis we have the age, and on the y-axis we have the count of gymnastics people. So it could be male and female. So with the age, how it variates, how the counts of the gymnast variates with the specific age. Okay, so this slide is about creating distribution from data like definition. So what is a random variable? So it's basically quantity with values not known with certainty. So random variable means like it can be any value inside the variable. Variation means, like as the word suggests, that there is a differences in a variable measured over the observation. So maybe today one observation is one value, tomorrow it will be changed to the different values. So with the passage of time, sometime with the passage of time, sometime with the other variables, when the values change, that is called a variation. A frequency distribution describes the values of variable and how often they appear in the data. Like, so there are two kinds of data, as I told you that in the beginning in the learning objective, that categorical variable, which are consisting of labels, for example, names for which the arithmetic manipulation is impossible. For example, categorical variables could be like, male females. Categorical variables could be like a survey option, like agrees, strongly agree, strongly agree, and disagree. and strongly disagree and neutral. So this could be like, categorical variable, and we need to transfer this categorical variables into quantitative by assigning some numbers. But directly we cannot do any manipulation, we cannot do any arithmetic operation on that one. And for quantitative variable, yes, we can do some mathematical operations like plus, minus, divide, multiplication. That is possible. And what is a sample? So sample is a small part of a population. For example, in Bahrain, we have like Bahrain is, let's suppose, the sample for our research. Then one of the area like Muharrak or Zalak or any part could be a sample in that case. Visualizing a frequency distribution. So how we can visualize a frequency distribution? So you can have some column chart on it. So these are the 5 different steps you can apply on the data. And so first, what you need to do, you need to select some cells from, let's suppose, from A1 to A51, let's suppose, and then you need to click on the Insert tab on the ribbon. And after that one, in the step number 3, you go to the recommended charts, and in the recommended charts, you can click on Insert charts dialog box and select the cluster column, and then click OK. So then you can click any column in the chart that appears while the columns are selected, and then if you right click on any column, then you can select on the sort option, or you can click on the sort largest to smallest option to make it sorting descending or ascending. So this is like, one of the frequency distribution. So this accounts for Coca-Cola is 190, counts for Pepsi is 130, counts for soft drink purchase. So how many people purchased Diet Coke, how many people purchased Sprite, and how many people purchase Dr. Pepper, right? So these are the different count frequency. So frequency means that the number of people who uses certain soft drinks. Now then we have relative frequency distribution, that how the relative frequency distribution can be done. So you need to create a frequency distribution for categorical data using the COUNTIF. So you can apply some COUNTIF function, and then in the COUNTIF functions can be used to have a relative frequency distribution. So how you do the COUNTIF function? So it's very easy. So how you have to do it? Let me show you. Here you can for example this one, yeah. So you need to put an equal sign over here, and then you need to select, when you say count equal sign count if, and then you need to select the specific columns which one you want to count it. And similarly you can have percent frequency as well, by dividing it by the sum. So the, for example, d2, so this is the d2, this is 2, okay, and this is your d, right? So this is like, so this will, this way, items would be d2, and this would be d3, and this would be d4, right? And similarly d5 and d6. So here you can see over here that soft drink purchases and the bin, and then frequency. So frequency is that how many times the Coca-Cola was taken, and the percent frequency. So percent frequency means out of 100 and out of the total, how it will look like. So it is 38%. So the total would be 100. So the percent frequency, whenever you just like add it up, it would be 100, right? So 38 plus 16 plus 10 plus 26 and plus 10 would be 100. Okay, yeah, so there are certain formulas for your calculation. So you can apply this one, and you will find like what are the different formulas. For example, relative frequency is like frequency of the bin divided by the total number. And then we have some probability distributions characteristics as well. So what is the probability distribution characteristics for random variable? So a percent frequency distribution estimate a probability distribution. So here we have, let's have some examples on it. So there is a application of Benford law. So last time we talked about the Benford, that certain elements or certain numbers, they are like more chances to be repeated, like one is has more chances to be repeated in a certain numbers, or in accountancy 2 has a little bit lower chances, 17%, 3 has 12.5%, and similarly 9 has the lowest chances to come in a number, which is 4.6%. So this is called a Benford application, and we put the frequency analysis with of the frequency analysis with respect to the Benford law. And then for usually for quantitative kind of data, we go for, like, histogram. So I think in chapter number 2 you have already drawn this one, so I'm not going to repeat these kind of charts. These are very say easy charts for you. Then you have, like, definitions, build a histogram definition and application. So you can have some more, like, calculations on the certain data. You can find the frequency. You can concat means if you want to add two texts, like text number 1 and text number 2, so concat function can also be applied in the Excel. The method is same, just like the frequency method. You need to put the equal sign as it is put over here. As it is put, the equal sign is very important, and then you can go for concat or frequency. So this is the manual histogram. We all need to know about that one in chapter number 2. Histogram for the death data for a certain place. So how the death data has been distributed. So if you see over here, the death rate is more in the ages of 77 and 84, and then in 84 to 91. So let me draw this for you. Like, this one is the highest, okay, this one is the lowest, right? No, not lowest, comparatively lower than this one, and this is on third one, and this is on the fourth, right? And this one and this seems almost similar, and people die less in the age of 49 and 56, and here is a little bit more lower, and this is more like, at the age of 7 and 14, the people are more, like, healthier and robust. Okay, so number of bins on histogram. So in the, yeah, so this is like a more statistics. So here they have make some groups from, like, from age 31 to 43 and 43 to 55. So we made a cohort of this one. So the cohort can also be analyzed with respect to the count of the people. So how many people have the death ratio with respect to the different cohorts. This chart is called kernel density chart, and this kernel density chart can also be seen, and how it looks. It has a good view, and this can also be, like, drawn, and it will show you the probability density with respect to the age of at death of with respect to the years. Yeah, this is very important with respect to statistic, the skewness in the quantitative data. Sometimes it is symmetric. Symmetric means, like, either it's not left skewed nor a right skewed, right? So usually, let me describe this for you. So this is, like, symmetric. It is not neither left or not right. This is called left skewed. So although it looks to the right, but we call as a skewed left. This one, it looks to the left, but we call it as a skewed right. So you must be a little bit careful in that one, especially in MCQs kind of questions. And this is called highly skewed right. Okay, this is highly skewed right. So these are like different examples. So comparing the distribution, the frequency polygon. So let's see some more examples for the frequency polygon. If you see over here, this is the same example in a different perspective. With the perspective of the polygon, you can see over here, these you can compare these two graphs. Okay, and now this one is called the trellis display, of the length of state distribution for 3 hospitals, right? So this is the data for the 3 hospitals, Seattle Grace, Seattle West, and Seattle Sloan Memorial. So this is the data for these 3 hospitals, and they have vertical and horizontal arrangements of individual charts of the same type, size, scale, and formatting. And this one you can have it like displaying individual value, the strip chart. So this strip chart is a bit different with different kind of dots you can see over here for distribution with respect to the male and female data, and you can see